Are you ready to give dead rail a try? Suppliers of wireless control systems for use with dead rail, Part 4. Links to the following suppliers are listed in the description below this video. Some of the current suppliers of wireless control systems that can be used for dead rail. CVP Airwire. Two systems are available for dead rail. Airwire 900 for large-scale trains. Airwire 900 for small-scale trains. CVP Airwire 900 for large-scale wiring diagram. Notice that the maximum continuous motor output current is about 8 amps using 10 to 24 volts. CVP Airwire 900 for small-scale simple basic wiring diagram. Notice that it can use a continuous 1.5 amps and 5 amp peak. Its voltage is from 8.2 to 18 volts. CVP Airwire 900 for small scale wiring diagram with DCC decoder. Here the decoder's amp rating is more important than the CVP board. These are the choices for the CVP Airwire 900 throttles. This is the Stanton S-Cab. It can be used with HO, ON3, and ON30, and some S scales. The maximum current is 1.2 amps and the voltage 6.4 to 20 volts. This is a combination of Tam Valley Depot and Blue Rail that uses a 2 amp small scale board and a 5 amp large scale board. On their website they notice Go Dead Rail with the Battery Buddy. The throttle is a smart device, phone, or tablet using the Blunami app. Tam Valley Depot, Blue Rail. In basic mode, both of the available boards can be used without a decoder to control motion and lights. The small scale version is shown, but the large scale is also available and shown on their website. This is the 2 amp version. Tam Valley Depot, Blue Rail. This diagram illustrates the use of the Blue Rail DCC board with any brand of decoder. Tam Valley Depot, Blue Rail. A few other interesting notes from the web page. Power 11 to 16 volts. Regarding the 2 amp board, use HO, S, and O scale with CAN motors. It is important to remember that the limiting current factor might be lower than 2 amps if the decoder is rated for less. Soundtraxx Blunami. There are currently 4 versions of the Blunami decoders. They are all based on the Tsunami 2 with a low-energy Bluetooth circuit added. Blunami BLU 2200 is a wired universal-style sound decoder with maximum motor amp stall current of 2 amps using 7 to 22 volts. The Blunami BLU 21P NEM8 is a 1 amp digital sound decoder with 8 function outputs using 7 to 22 volts. The Blunami BLU 4408 is designed to wirelessly operate models with higher stall currents such as some S, O, and large-scale locomotives. The maximum motor stall current is 4 amps using 7 to 27 volts. Soundtraxx Blunami BLU PNP8 is a universal factory board replacement sound decoder suitable for use in many manufacturers' diesel models such as those made by Atlas, Athearn, and Intermountain models. It is suitable for a wide variety of models from HO to S scale. Its ratings are 2 amps and 7 to 22 volts. The iOS version of the app is on the left. The Android version is on the right. LocoFi. LocoFi uses Wi-Fi to communicate between its decoder and an Android or Amazon Fire device. LocoFi 3 Wi-Fi sound decoder for HO locomotives includes the speaker already attached and has a 1 amp maximum motor current. 7 to 24 volts. Large-scale modification plug-and-play package for LocoFi 3 includes all of the parts to modify the decoder for use in a large-scale model drawing up to 13 amps by using a MD13S H-bridge. It also includes an attached large-scale speaker, 9 to 24 volts. LocoFi is very easy to install since there are only 7 wires to connect and the speaker is already attached to the decoder. The free LocoFi app is very easy to use. Choosing your first dead rail project conversion. Document everything you think, learn, and do with notes and photos. I have found, as well as many others, that using a diesel with a trailing battery car is easier to convert than a steam engine for your first dead rail project. No matter where you are in model railroading, the locomotive for your first dead rail project must be in good working order and running well. Test it. While running the locomotive, observe the headlight. If the light grows brighter when going from low throttle to high throttle, it might be indicating that it is an incandescent bulb and might need to be changed to an LED. This needs to be confirmed when the locomotive shell is removed. A locomotive with a CAN motor installed will have a much lower stall current than an older open frame motor. Therefore, it makes a better choice for your first dead rail conversion. The next thing to do is to determine the stall current of the motor. Knowing what the stall current is helps to determine which decoder and system to choose. Maximum currents were noted for the previously explored systems. A link to a video on how to check the stall current is in the description below. If an app is required for your chosen system, download it onto your device. Before removing the locomotive's shell from the frame, learn as much as you can about the system or systems that you might want to choose. Read and take notes from the manufacturer's website and a Google search. Also, view as many YouTube videos as you can find regarding that system or those systems. Remove the locomotive shell and carefully observe what you might need to do. The electrical pickups from the track need to be isolated from the decoder, either by removing the connections or isolating them with a switch. I prefer to remove the connections as that process aligns with the KISS principle and doesn't add a component, the switch, with more wiring. If the locomotive is DC only, be sure that the motor is isolated from the frame. How to do that is demonstrated in a video linked in the description. Plan how to get the new power leads out of the locomotive and back to the trailing battery car. All of the systems should work well with DC locomotives once the motor has been isolated. If the locomotive is DCC ready or already DCC in sound, I recommend using the appropriate Soundtraxx Blunami decoder. A locomotive with DCC in sound already installed is pretty much ready for nothing but a decoder exchange to an appropriate Blunami decoder. A DCC ready locomotive may or may not have a speaker installed. Therefore, the appropriate Blunami decoder and maybe speaker will need to be installed. Route the new power leads out of the locomotive to go back to the trailing battery car. Use the battery pack to test the system before replacing the locomotive shell. Replace the shell. Make any necessary modifications to the trailing battery car that will make battery access as easy as possible. My website has useful articles on the 4 dead rail conversions I've completed. They are linked in the description below. Resizing the browser window, as shown in the screen capture, makes reading my website much easier. I suggest that my website should be checked, at least on a monthly basis, to see what I've learned, relearned, and where I'm going next with this project. In August of 2025, New and revised information was added to my website. If you have questions to ask or comments to share, my email address is linked at the top of my webpage. I would love to hear from you.